Hey guys, this is your friendly neighborhood math teacher, Mr. Bennett. We're going to cover 4.3b today. It's going to be a little bit different than usual. Um, Today, we're going to look at when we can extend results of um, an experiment to our entire population, and if we can actually determine whether or not there was causation um, because of our treatment. So, if you look at our topic today, it says some students at your school claim that taking an SAT prep course will help improve their SAT score. Design a study to help discover if this claim is true. Here are 6 proposed studies for investigating the question of the day. Suppose we found that the mean SAT score of students who took an SAT prep course is significantly higher than the mean SAT score of students who didn't take an SAT prep course. What conclusions could we make? Can we generalize and can we determine causation? And use the sentence frames to help. And I'll explain what that means in just a second. But first, we want to talk about the fact of generalization, right? How can we generalize our data to cover an entire population or the entire population of whatever we're studying, not, the entire population of the world or anything. But in this case, we do that, right? How can we generalize? We do that by random sampling. Okay, when we take a random sample, that allows us to then generalize it because it's not just, we're not taking data from a specific set of people. Like, we got a random group, so, theoretically, if we got other random groups in that same population, we would see similar results, is kind of the expectation. And can we determine causation? Right, so we've talked in this unit about causation versus just association. And so how do we determine causation? That's by using random assignment. Right, when we have our 2 different treatment groups, are we randomly assigning them so that is not an issue? And we can then say that, yes, these are actually caused by our treatment, these results. So what I would want you to do first is for these 6 different studies here. So we have 6 different proposed studies. For each one, I want you to go through, and on the left-hand side, you'll see I already have written random sampling. So go through and label whether or not yes or no does each one include random sampling. And then on the right-hand side, again, same thing, yes or no. Does each one include random assignment? So for example, if we look at question 1, or study 1, get all the students in a senior-only class to participate in a study. Ask them whether or not they took an SAT prep course and divide them into 2 groups based on their answer to this question. So we can pretty clearly see that through this study, there was no random sampling, and nowhere in that description did it mention any random assignment. So there was also no random assignment. So I want you to go through each of those 6. You guys can talk about it in your groups and kind of double check with each other what you guys think. So I'm going to give you guys a minute to do that. So go ahead and pause the video, and then I'll go through the 6 and put the answers on there. But I want you guys to try it first and see how you guys do on your own. So pause the video, and then we'll come back and I'll share the answers. So number 2, yes, it has random sampling, but no random assignment. Study 3 is another yes to random sampling, but again, no to random assignment. 4 is a no to random sampling. There's no random sampling here, but it does have random assignment, which is nice. 5 is a yes to random sampling, and also a yes to random assignment. And then question 6, or study 6, This is actually the same thing. Yes, there is random sampling, and yes, there is random assignment. So, what are we going to do or how are we going to determine whether we can generalize these, or what can we say is the result of these different studies? So what I've done for you today, I've linked this in your Canvas course, is I've included this Google Slides activity, okay, this matching activity. And so on slide 2, you'll notice you guys are split into your groups that you basically normally sit in. There's nothing crazy there. But I want you to notice each of you has specific sets of slides to work on. They're the same slides. I just duplicated them so you guys have your own set to work on so you don't mess with the other groups. So for example, I'm going to mess with group 1. And so slide 3 says match each study design with the conclusion that can be made from it, then write the conclusion down on your notes. So all of those white boxes, 1 through 6, are the studies that are listed in our activity sheet. And then the black boxes down at the bottom are different possible outcomes, different conclusions. And so they are currently just alphabetically in order, A, B, C, D, E, and F. But what I want you guys to do is within your groups is to kind of match them with the correct situation, correct study. So for example, if I think A belongs over here with number 2, I'm going to go attach that to the end of number 2, and I'll put B over here with number 1. Okay, I'm not saying those are the answers, I'm just saying like that's what I would want you to do. So you're going to kind of read through the possible outcomes, try to figure out which ones you think go where, right, and just kind of match them up with their respective study. Okay, so that's your first slide for each of you. So each of you in your own little groups, you have that slide. And then the second slide is which studies allow for generalization to happen. So we kind of talked at the beginning of this video, what allows us to have generalization. So again, you'll just tap in this little text box here, say situation number 4, right? Or whatever you think it is. And then the next one is which ones allow us to determine causation. Very similar. I've given you all 6 here. Just type in which situations you think they are. And then the last slide is generalization versus causation. What aspect of a study allows us to generalize to a larger population, and what aspect allows us to determine causation? So again, just write 1 to 2 sentences. Again, you guys can just do that within your group. Like I don't need 4 different answers to this. Just you guys decide as a group what you want your 1 or 2 sentences to be. And that's it. Okay, so you're just kind of using this to kind of manipulate and kind of put your thoughts together. So what I would do if I were you is I would go ahead and in a moment pause the video, kind of work through that, take a few minutes, work through those questions, feel like you guys get to a point where you think you're good, and then I will actually display the answers here on the video. I'm not going to write all the answers out in the notes. I'll let you guys do that. I just don't think you need to sit here for 10 minutes watching me write stuff that's already on the screen. But I will put the answers in the video so you can check and see, did you get it right? And then we'll come back and then finish kind of the wrap-up section. So go ahead and pause it now. Take some 5-10 minutes or so. Talk about it within your group. See what you guys can come up with your 4 slides. And then play the video, and I'll kind of show you guys what the answers are, and we'll go from there. So go ahead and pause it now. So for our first slide, okay, we have these answers. So question 1, the conclusion was letter C. For the students in this class, there's an association between taking an SAT prep course and a higher SAT score. So again, there's an association, not causation on this one because we don't have that random assignment. Number 2, for all seniors at your school, letter E, there's an association between taking an SAT prep course and higher SAT scores. Again, there was no random assignment, so again, we can't say that there's causation there. And then question 3, selecting a random sample of students. we have letter A, for all students who have taken the SAT at Sanger West. There's an association between taking an SAT prep course and higher SATs. So again, we can kind of generalize that to our entire population because we have random sampling there. We can generalize it to the population of students who've taken the SAT. But there's only an association, right? Because we still don't have that random assignment. Number 4 is letter D. Number 5 is F. And 6 is B. On the next slide, so those you're going to want to write down in the conclusion section, right? You can put the little letter and then the statement in your notes. So I will put that on the completed version of the notes, but for the sake of this video, I won't worry about writing it all out. The second slide, which studies allowed for generalization, were studies 2, 3, 5, and 6, because again, those were the ones that had random sampling. Which ones cannot generalize to the population are 1 and 4, because they did not have any random sampling. Your third slide, which ones allow us to determine causation? So these are the ones with random sampling. And I actually made a mistake here. I apologize. I wrote these in the wrong box. So we're going to fix this in real time. So those should actually be 4, 5, and 6. And cannot should be 1, 2, and 3. I apologize. So what happens when you work too fast and you're trying to rush? So I apologize for that, but the can determine causations 4, 5, and 6, because those are the ones that did have random assigning. 1, 2, and 3 did not have random assignment involved, so we can only do association with those. We can't actually use them for causation. Okay. And our last slide, generalization versus causation. Again, random sampling is what allows us to generalize to a larger population, and random assignment is what allows us to determine causation. Okay, so those are kind of the two big key points for really this entire lesson. Okay, and really that kind of also is a good just kind of like singular statement for all of chapter 4, to be honest. It's kind of a lot of what we've looked at, right, is the different types of random sampling and assignments and stuff like that. So really, really important there. So I'm going to jump back to our notes. So again, you want to fill that out. Okay, I will do that in the completed notes section. Again, you'll just put, for example, number 1, you put C, and then whatever the statement was for the students, ... right? Finish that up. Write all those out so you've got them down. Or if you want to take screenshots and put the screenshots in, I don't really care. These are your notes. You do what you want to do. But I'll write them out for the completed notes. But to kind of wrap this up, the scope of inference. Okay, what is that referring to? Okay, it's just what can we infer based off of the type of study that we've done, right? The scope just meaning, are we stuck to only being able to talk about the sample, or can we generalize this to the entire population? And can we use this to discuss causation at all? Okay, that's what it's talking about, the scope. It's kind of how broad or how wide can we cast our results based off of the type of study that we've done. So learning target number 1, referring to extending from a sample to a population. So we have this population of people out here, or whatever we're studying. And from that population, we're going to take a random sample. And random sampling, keyword there, random sampling, allows us to generalize conclusions to the population from which it we sampled. from which we sampled. So I can't just generalize it to the entire population of the entire world, right? But if the population was specifically like seniors at our school, right, then we can generalize it to all seniors at our school. I can't just say all seniors in the entire world. I can't just say all students in the entire world. But from the population we took a sample from, we can generalize it to that population. And then learning target number 2. Again, can we determine whether or not we can see if there's a causal relationship, right? If we have causation from our results, from our treatments. So as an example, right, we have our 30 students. We then need to do random assignment into 2 groups, right, with different treatments. 1, group 2. And I'm going to rewrite those. Whoops, sorry about that. I'm going to rewrite those because I don't like the way those look. Sorry. So group 1, group 2. And so again, the key here, right, is that random assignment is what allows us to say a treatment causes the change or changes in the response variable. So without that random assignment, we can only say that there's an association between the two. Like they are kind of related, but I can't say it directly caused it, right? It wasn't the reason for that outcome. And since this is already fairly short, I'm just going to kind of quickly go through this check your understanding question down below. If you want to not listen to this, you can. That's fine, but I'm just going to quickly go through it because it's pretty straightforward. So number 1, Zach works at the Verizon store and wonders if phones last longer if the screen's brightness is set too low. He selects a random sample of 20 brand new phones from this store. So keyword there, something to highlight, right? Random sample of 20 brand new iPhones from this store and randomly splits them into 2 groups. Randomly splits, important to know, into 2 groups of 10. For the first group of 10 iPhones, he sets the screen brightness to low and then starts a movie. For the second group of 10 iPhones, he sets the screen brightness to high and then starts a movie. For each iPhone, he measures the amount of time until the battery is all the way dead. He finds that the low brightness iPhones lasted longer on average than the high brightness iPhones. So was this an observational study or an experiment? Explain your reasoning. So this right here is an example of an experiment. Because there was a random assignment to the treatments. Part B, what is the explanatory variable and what is the response? Our explanatory was screen brightness. Right, thinking also kind of, high or low, low or high. And then the response variable was the amount of time until battery is dead. Part C was a random sample used to collect the data. Yes, it was, right? We highlighted that early on. There's a random sample. Part D, was random assignment used? Yes, there was. Because again, we have that randomly splits. Okay, that is our random assignment, even though it's not quite as academic of language, right? Randomly splits, but it is random assignment. And so part E, what conclusion can we make? Is that for all brand new iPhones from this store. So remember, right, this part right here comes from the random sampling, right? We can now generalize it to the population that we took it from. And what did we take it from? We took phones from this store. So I can't generalize it to all iPhones because I didn't just take a bunch of iPhones from everywhere. I specifically took it from this store. But I can generalize it to all of those from this store, not just the sample. A low screen brightness causes increased battery time. And again, we can use causation here. We can claim causation because we did have some random assignment. Okay, so random sampling allows us to generalize that to the wider population of new iPhones from the store. And then the random assignment allows us to discuss causation. So there's kind of a little two-way table here. It's kind of stuck in there. Were individuals randomly assigned to groups, yes or no? Were individuals randomly selected, yes or no? And so we can either generalize to the population or talk about causation based off of that. If we have random selection, right, random sampling, then we can generalize to the population, no matter what. Okay, if we don't, then it's a no. And similarly, if we have random assignment, then yes, we can do cause and effect. And if not, no, we can't. Okay, so that's just kind of a nice little graphic there you may want to make a note of, but that's kind of the general idea here. Okay. If you have questions, let me know, but hopefully that helps. Hopefully that was a little bit different and kind of fun. But otherwise, I will see you guys on tomorrow, whenever I see you again. Have a great rest of your day. Like I said, if you guys got questions, let me know. Otherwise, this is Mr. Bennett logging out. Hope you guys have a great rest of your day.